This channel, Kitab Nikal, welcomes you with a warm greeting. In today's class, we'll be dealing with force and laws of motion. So, the very first thing what comes into my mind by listening to the heading of the chapter is force and laws of motion. So, you might have already read about motion in previous chapter. Here we will be reading about force and certain laws of the motion. You might have read about in previous chapter about the motion in a straight line and the motion on a circular path, uniform motion, non-uniform motion. In that you might have read about velocity, acceleration, initial velocity, final velocity. Right. So we'll be using all those things in this as well. So here we'll be reading about force and laws of motion. So, the very first thing that comes into my mind is what is force. A push or pull upon any certain body is called as force, right? So, if there is a marker, if I push this marker on this side, then the force acting upon this body will be towards this direction. So it will move in this direction. If the same amount of force is applied from this side as well, when I am pushing from this side, and certain amount of force is applied from this side as well, so what will happen? Then the both forces from both the sides will be same, and at last this will attain rest, right? Or attain the same amount of velocity what it had before, isn't it? If this is moving with a certain velocity for sake, if it is moving with a velocity of 5 meter per second, if I push it even with a force, then the velocity might increase if I am pushing from this direction, right? Or else, if I push it from this direction, then the velocity might decrease, right? So we know about it, we know this much about it. So if an object is put simply at rest, and if we apply force from one side, it will tend to move in the direction of the force applied, isn't it? It will tend to move in the direction in which the force has been applied. The force has been applied in this direction, so the object also will move in this direction. But if the amount of force applied in the opposite directions means that if an object is pushed in this direction and with the same amount of force it is being pushed from this direction as well, then what will happen to the object? It will remain at same position. So force is basically characterized in two types, like balanced force and unbalanced force. So what is balanced force? Balanced force means that an object is attaining an external force in a certain direction and the same amount of force is applied from the opposite direction as well, then it is said that the object is having a balanced force. If an object is pushed in one direction and it moves towards the direction of an object, it means that the force applied from the opposite direction will not be same. That is the reason why it has moved towards the direction of the force. Force, the SI unit of force is Newton, right? You might have been knowing that. Newton. We denote it with a capital N. Newton was a scientist, Isaac Newton, right? About whom you say that the apple fell upon his head and he discovered gravity, what is force. To discover all these things, he invented calculus and so on. So he was a genius. So you must know his name, Sir Isaac Newton. We say ISAAC, Isaac Newton. Now the basic thing about the force you have come to know, that balanced force and what is unbalanced force. Right? If the force acting in the both from the both of the direction in a certain fixed amount, if the force is same, the magnitude of the force is same from both the sides, then it is said to be a balanced force. Means the magnitude of a force is same while the forces are acting in the opposite side, in the opposite directions. Then it is said to be a balanced force. What is an unbalanced force? When the magnitudes differ while the force is applied in the opposite directions. Right? So the object tends to move in the direction of the higher magnitude force applied. Right? So this is the basic thing we know about the force. Now I just want you to narrate a simple story, or let's do certain practical. Suppose there is a inclined staircase and the same staircase on the opposite side as well. This is the surface. So the height of this inclination and the height of this inclination will be same. If I put a marble over here and release it from here, applying cert, if I put a marble upon this tip and just give an external force, a little bit of external force, so that it comes in motion. So what will happen? It will move, it will go down. Then again, it has gone with certain velocity. What will happen? It will go upon this to attain the maximum height. Right? If the inclination is same, then the distance it has traveled from the tip to here, then it will also go up to the tip. Right? And it should endlessly do that, right? Because the moment it is released from here, it should go above up to the same height, right? Or else the force will be decreased. So it was Galileo's thought that if we put a marble upon the inclination and we release, it will go in this manner up to a certain height, and it must be continuing for endless. It must be continuing endlessly. But that does not happen. Slowly the speed reduces and it will gradually attain less height on both the sides, and at last it comes in the center, right? So he was thinking about it, and after certain time, what happened, that Newton took that idea and said one thing, that the tendency of any object, हमारा भी वही, the tendency of any object is to attain the same motion. For say, if an object is in motion, tries to be in motion until and unless any external force is applied upon it. If an object is at rest, suppose you are sleeping, you are over your bed at 5 o'clock in the morning in this chilled winter, and if you are asked to come out of your bed and give a glass of water by your parents, then it would really make you very angry. But yeah, but you will not be saying anything because they are your parents. But you'll try to attain that rest. You'll try to somehow manage. If you have younger siblings, you'll try to order them to bring the glass of water instead of you going there. Right? So that is the behavior. If you are at rest, if you are at rest, you will try to be at rest. Right? For suppose, if I have a pen over this book, if I just move this book, what will happen? The pen will not be going along with the book. Why? Because now the pen is at rest. And if I just move this book, then the pen also should move along with the book, right? But the pen does not move along with the book. The pen does not move along with the book because every object tries to be in the same motion. The pen was at rest and the pen wanted to be at rest. So the force was applied just upon the book. So the pen said to book that you move, I do not want to. That is called as inertia. And the Newton gave three laws according to the Galileo's thoughts. The very first law of motion is called as law of inertia. And inertia is basically of three types. The first one is inertia at rest, second one is inertia at motion, and the third one is inertia of direction. So in inertia of rest, it is said that an object at rest tries to be at rest until and unless some external force is applied upon it, like your mother's slipper comes over your face to wake you up, to leave the bed. Then suddenly you just get up and run out of the bed, right? In the same manner it happens when an object at rest, if an object is at rest, it tries to remain at rest until and unless some external force is applied upon it. Then the next is inertia at motion. If an object is motion, tries to be in motion until and unless some external force is applied upon it. And one is of direction. Then slowly, gradually we will be moving upon it as well. But the first thing I want you to tell here is the examples. So it would be better for you to understand it. And if we are talking about the inertia at rest, then suppose you are very relaxing over a seat, or I have just given an example of a pen, but let us take few more examples. You are sitting in a car, you are relaxing in a car, you are relaxing really well, and suddenly the car starts moving. What will happen? If you are sitting ideally, then you will tend to go backwards, right? If a car accelerates, or if you are sitting on a bike and suddenly the bike accelerates, then you tend to go backwards, right? It means that you wanted to be at that place. You wanted to attain that restness because initially you were at rest position, isn't it? In the same manner, if a brake is applied, if a sudden brake is applied, then you were in motion, you wanted to be in motion, and hence if sudden brake was applied, you move forward, right? It meant that you wanted to be in motion. That is the reason why you, even after the brake was applied, you wanted to move even further than that, right? Isn't it? So that is called as inertia at rest and inertia at motion. An object in motion tries to be in motion until and unless some external force is applied. Inertia at rest is an object at rest tries to be at rest until and unless some external force is applied upon it. Then one is inertia of direction. An object moving in a certain direction tries to be in the same direction until and unless some external force is applied in different direction. For example, you are moving in a car. You are going in a car, and suddenly you are standing in a bus, in a heavy crowded bus, and driver suddenly turns the steering towards left side. Then what will happen? You will tend to move towards your right side, right? If the driver moves the steering towards left side and moves the bus to the left side all of a sudden, then what will happen? You will try to move towards your right side because you wanted to be in the same direction, but the direction was changed by the driver. It means that if the vehicle moves sudden towards your left, then you go towards your right. If the driver moves towards right side, towards your right side, then you tend to go towards left side. right? If a driver applies a sudden brake, then you tend to move forward because you wanted to be in motion. If a driver applies, if a driver accelerates all of a sudden, you tend to go backwards because you wanted to be at rest, right? So, this is the law of inertia: inertia at rest, inertia at motion, and inertia of direction. So, this is called as law of inertia. For suppose if you have hit a football, then the football tends to move in air. It goes and goes. You might have seen. If the object is put ideally, if the football is put ideally, force is applied upon the football. It was initially at rest, it wanted to be at rest, but it did not attain that. Due to some external force applied upon the football, it moved. It went to a certain height and it was going and it wanted to be, now it wanted to be in motion. So it tried to be in motion, but the whole force was consumed up to that and it slowly gradually falls down. Right? Suppose instead of football, if you take that big rock instead of a football and if you try to kick it, would it attain the same height, or you might get hurt? You would be hurt, your leg will break. So if certain things happen, if the football is taken and hit by you, then the football attains certain height, but a huge rock is taken and hit with the same force, your leg will break. Why does that happen? It means that the inertia and the mass is somehow, it can be compared, or it can be thought of, we can think about it, right? It means that if a heavy object is put, then we will have to apply greater force upon it, right? If a lighter object is put, we'll have to apply lesser force upon it. It means that if the mass of an object is more, then it will attain more inertia, right? It will try to be in motion, or it will try to be in rest for more time, for it will have to apply more force to change its motion from rest to motion and motion to rest. We'll have to apply greater forces, isn't it? So this is the first law of motion. If we move to the second law of motion, before entering into second law of motion, there is a term called momentum. I want you to understand what is momentum. Momentum simply means that कितना दर्द हो रहा है, कितना चोट लगा है, how much you are getting hurt, or how much you are getting injured by a certain impact. For example, you are moving on a road, you are going on a road, and you see a truck is coming, and beside that truck, a bicycle is coming. And if you have only two choices, that if whether you are going to get hit by the truck or by the bicycle, what would you choose? If you are intelligent enough and if you do not want to die over there, if you do not want to commit any sort of suicide out of love failure or something, then you will choose that I must be hit by the bicycle so I would get lesser injury, lesser impact, right? But why is that so? Why do you want to hit by the bicycle? Because the bicycle's mass is very less and the speed even attained by the bicycle is less. So, whether the mass is less or the speed is less, the momentum will be lesser, the impact will be lesser, right? If you are hit by the bus or the truck which was coming towards you, it has very huge mass and it is moving with a particular huge velocity. So, when it will collide with you, it will crush you, right? It will not even leave a bone if you are lucky enough, or else you'll just be handicapped. So, so the thing would be, If the mass of a body and is more and the velocity is more, then the impact will be more. ज़्यादा दर्द होगा, ज़्यादा चोट लगेगा. If the mass of a body is less and the velocity of a body is less, then the impact will be less, right? So momentum is defined by p, denoted by p, and generally we denote momentum with p, small p, and it is defined as the product of mass and velocity. An object has certain mass, and if it attains certain velocity, the product of the mass and the velocity will show the impact, will be the momentum. Do you understand what is momentum? Momentum means, suppose if you are hit by a bullet, if you are standing, there is a robber comes and shows a gun towards you and asks you to raise your hand. You are just raising your hand, you are standing. Now the robber tries to rob you, and you just try to make certain find certain things to not let him rob you, or if you are brave enough, you want to fight that robber even he's with the gun, and suddenly he fires it up. If a robber fires a bullet up, towards you, though it has very less mass, the bullet has very less mass, right? Though the bullet has very less mass, it will impact upon you. The impact will be very huge, isn't it? The impact will be huge. If the Why is that so? Because the velocity is far more, right? The velocity of the bullet is moving with a very high velocity. That is why even the negligible masses moving with very high velocity can impact more, isn't it? So the momentum will be more. So if the velocity would be more, though the mass is normal, less, more, or very huge, if the velocity will be more, the impact will be more, the momentum will be more. For suppose if the mass is very huge, if a very huge block of mass, for suppose 1,000 ton of mass is there, and it moves with a very less velocity, even then the impact will be more. So if any of them is more, then the impact, the momentum will be more. So momentum is the product of mass and velocity, right? So we know about the momentum. Now the Newton said in his second law of motion that the rate of change of momentum is directly proportional to the unbalanced force applied in the direction of the object. हैं क्या बोल गया sir? What was that? All right. Just we'll try to make it. Where is my duster? Let us try to understand what I have already said now. Oh, I wrote it with a permanent marker in the last class, and I could not upload that class because I have uploaded a story instead of it. I recorded a video, and in that my audio was missing, so I had to leave it. So I had to record it again while sitting. I was really frustrated that I have recorded it. It was a video of more than an hour. I had recorded it, and then eventually I see that the sound was not there. There was an issue. There was not even a single wave of sound. So I had to leave it. Now I want you to listen to the second law of motion once again. The rate of change of momentum. Change of momentum. Change means final momentum minus initial momentum. Change means the rate of change of momentum. So we generally write delta in the place of change, right? The change in the momentum means delta p, right? Change in momentum. The rate of change of momentum. Rate means at how much time it is taking, at which rate it is changing, in how much time, in how many seconds or minutes or hours the momentum is changing. Right? The rate of change of momentum is directly proportional to the unbalanced force applied in the direction of the object. समझ में आया? How do we write it mathematically? The mathematical expression would be the rate of change of the rate of time. The rate of change of momentum is directly proportional to the unbalanced force applied in the direction of the object. So Newton has said it. Now I know that at certain rate, at certain time, the momentum is going to change. And in certain time, the momentum will be changing. If the momentum changes in certain time, that will be proportional to the force which will be applied. It means that if the force will be more, so the momentum, the change in the rate of the momentum will also be more. If the force applied is less, then the change in the momentum with certain rate will also be less. In other words, if I want to tell you, then if the rate of change of momentum is very less, it, it means if the rate of change of momentum is very less, it means that the momentum has changed but it has taken more time, then the force will be less. The rate of change of momentum was very high, means in very small fraction of second, in the very less time, if the momentum has changed, it means that momentum was very high, so the force will also be more, right? Isn't it? So we know momentum P is equals to mv. So let us write it. F is directly proportional to delta mv by t, right? Force is directly proportional to rate of change of momentum mv. So the mass will be same throughout the collision or throughout the impact. The mass is not going to change of an object, right? But the velocity can differ, isn't it? If the velocity differs, means that F is directly proportional to change in momentum. So let us remove the delta and put the change. What will be the change? mv minus mu, the final velocity and the initial velocity, right, by t, isn't it? Let us take out m common, v minus u by t, isn't it? And in previous chapters we have read v minus u by t, final velocity minus initial velocity by time is acceleration. So F is directly proportional to m a. Now it is proportional. To remove this proportionality, what we do, we take a constant as k. We take k as constant where k is 1. So F is equal to kma where k is equal to 1. So the formula goes like F is equals to ma. It means that force is equal to the mass and the acceleration. The product of mass and acceleration. How much acceleration the body was attaining means what was the final velocity. If we reduce the initial velocity from the final velocity at that point of time, how much time it has taken to move from that final velocity to from initial velocity to final velocity, in certain time, and what is the mass of the body, if you multiply both, means if you multiply mass of the body with the acceleration what it was attaining, then we can know how much force was applied upon the body, right? Then it is called as second law of motion, and here we have got a formula while deriving it. What is the formula? F is equals to ma. From where we have got, from the rate of change of momentum is directly proportional to the force applied in the direction of the object. Which force? Unbalanced force. Alright. Now, I want you to solve a question. You have in your exercise, there is a question given. Question exercise 8.1, if I say, a constant force act on an object of mass 5 kg for a duration of 2 seconds. A constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. Find the magnitude of applied force. Now, if the force was applied for a duration of 5 seconds, what would be the final velocity of the object? So this is the question. So what do we know? We have got certain magnitudes. So many magnitudes have been given. Like the mass is given 5 kg. All right, we'll be writing 5 kg. Then what else is given? Mass is 5 kg. Then time is given 2 seconds. Then mass is 5 kg, time is 2 seconds. From 3 meter per second to 7 meter per second. It means that initial is 3 meter per second and final is 7 meter per second. So we know certain magnitudes. Now what do we need to find? We need to find the magnitude of applied force. How much force is being applied upon the object? What would we do? We know F is equals to ma, right? But it is given in terms of initial velocity and final velocity. So what will we do? M v minus u by t, we already know it. The formula of A. We'll put the formula A. Now, what will we do? Just calculate it. Mass is 5. V minus u, 7 minus 3. Right? कितना होगा 4 by time 2. It will be 2 10 Newton. Force is 10 Newton, but that's not the only thing what it has been asking. Now it is asking if the force was applied for a duration of 5 seconds. We know the force. This 10 Newton force is applied for a duration of 5 seconds. Then what would be the final velocity of the object? The force was applied for, we do not know. We know that the time is 2 seconds. When the duration was 2 seconds, the force is 10 Newton, we have found it out. But what if the duration of time would be 10 seconds? Duration of time would be 5 seconds instead of 10 seconds. What do we need to do? We need to find the final velocity. So, same formula, F is equals to m v minus u by t. Now we need to find final velocity, isn't it? We need to find final velocity. The force was applied for a duration of 5 seconds. What would be the final velocity of the object? Right, final velocity we need to find. Send t to your left side. It is dividing here, so it will go to the left side and multiply. So ft, m will divide. Right, u is getting subtracted, so it will add. It will be added here. So now just substitute the magnitudes and you can find the answer. What would be force 10 Newton, time 5 seconds, so 50 by m 5, then it will become 10 plus u we know 3, 13, then final velocity would be 13 meter per second. So this is how the questions are done. If you would have understood the concepts, it would be very easy for you to understand. It would be very easy for you to do the numericals as well. So numericals are just a very easy cup of cake if you understand the basics, the concepts. If you know, then it would be very easy for you to understand it. Now the next thing what I want you to know is the first law of motion was law of inertia. Inertia at rest, inertia at motion, inertia at direction. Then we compared the inertia with mass as well. After comparison, in the first law, we came to the second law. The rate of change of momentum is directly proportional to the unbalanced force applied in the direction of the object. And from there, we have derived force is equals to mass into acceleration. So we have read about the momentum as well in this. Now, the third law of motion, I want you to know. What is third law of motion? It is very simple, the most simple law. Every action has equal and opposite reaction. What does it mean? It means that if I throw a ball with certain force towards the wall, if I throw a ball towards the wall at certain force, then ball will hit the wall and come back with certain force as well. Isn't it? If you walk, the force you apply on the ground to move forward, with the same force your leg will move. The force you apply on the ground, the same force your leg will move. If you want to jump up, if you want to take a huge jump, you will have to apply force in the opposite direction of the object. Right? It means the action what you do, every action what you do, will have the equal and opposite reaction. It means that the same amount of reaction will be done, isn't it? For suppose, uh, if I slap you over your cheek, that's it. The same amount of pain I'll feel on my hand, what you would have felt on your cheek, right? So it means that whatever the force is being applied, the same amount of force, the same amount of reaction, whatever the action is being done, the same amount of reaction is also there. For suppose you are standing, there is an activity given in your book, you are standing on a boat near the seashore, and if you want from the if you are standing on the tip of the boat and you want to jump over the sea, then you'll have to push your leg backwards to take a leap forward, right? So the boat will move backward just because of your force. If the boat is not that huge, then it can move, right? So that sort of thing happens. For suppose if you are firing a gun, the force applied on the bullet, what comes out, at that time it also gives a recoil, right? Jhatka lagta hai. So it gives the same amount of recoil, but it will not, remember, same, it will give an equal and opposite reaction, but it will give with the same magnitude, but it will not travel through the whole distance what it would travel, what in the action it takes. The reaction will not be the same as the action, but it will be of the same magnitude. जैसे कि if I slap you over the cheek, my hand print will be there on your cheek, but your cheek print will not be there on my hand, right? Up to certain case, isn't it? So this is how your chapter finishes. Thank you and have a nice day. My name is Ankit Raj.